Hello viewers. Welcome to the YouTube channel. In this video we will discuss about the model question paper which is from Government of Karnataka. Karnataka School Examination and Assessment Board. Model question 2024-25. For Class 12 or PUC 2 Physics, code is 33. This includes model questions of Paper 1, 2 and 3, Part A. Watch till end, and just do one like, share and subscribe. If you want a PDF copy, just comment as PDF. Let's start one by one. Model question paper 1, Part A. Pick the correct option among the 4 given options for all of the following questions. 15 into 1 is equal to 15 marks. 1. The SI unit of electric charge is A. Coulomb meter, B. Coulomb per meter, C. Coulomb, D. Per coulomb. Answer, C. Coulomb. 2. The angle between equipotential surface and electric field is A. 90 degrees, B. 0 degrees, C. 180 degrees, D. 45 degrees. Answer, A. 90 degrees. 3. Statement 1. The resistivity of metals increases with increase in temperature. Statement 2. Increasing the temperature of metals causes more frequent collisions of electrons. A. Both 1 and 2 are true and 2 is the correct explanation of 1. B. Both 1 and 2 are true but 2 is not the correct explanation of 1. C. 1 is true but 2 is false. D. Both 1 and 2 are false. Answer, A. Both 1 and 2 are true and 2 is the correct explanation of 1. Because the increased temperature causes the metal atoms to vibrate more, which increases the resistance to flow of electron. 4. A moving coil galvanometer can be converted into a voltmeter by connecting A. A low resistance in parallel with galvanometer. B. A low resistance in series with galvanometer. C. A high resistance in parallel with galvanometer. D. A high resistance in series with galvanometer. Answer, D. A high resistance in series with galvanometer. 5. When a bar magnet is suspended freely, it points in the direction of A. East-west, B. North-south. C. Northeast-southeast, D. Northwest-southwest. Answer, B. North-south. This is because the Earth's magnetic field points from geographic south to north, and opposite poles attract each other. Earth itself behaves as a magnet which causes a freely suspended magnet, or magnetic needle, to point always in a particular direction, north and south. 6. The energy stored in an induct of inductance L in establishing the current I in it is A. 1 by 2L, I, B, L, I square, C, L, I. D. 1 by 2 L I square. Answer, D. 1 by 2 L I square. 7. The direction of current induced in the loop ABC shown in the figure is A. Along ABC if I is increasing, B. Along ABC if I is decreasing. C. Along ACB if I is increasing, D. Along ACB if I is constant. Answer, C. Along ACB if I is increasing. The direction of the induced current in loop ABC depends on whether the current I is increasing or decreasing. 8. An ideal step-up transformer decreases A. Current, B. Voltage, C. Power, D. Frequency. Answer, A. Current. Because of the law of conservation of energy. This means that the total power in the transformer's primary and secondary sides are equal. When it increases the voltage on the secondary side, it must simultaneously decrease the current to maintain the same power output as the primary side. 9. The displacement current is due to A. Flow of electrons, B. Flow of protons. C. Changing electric field, D. Changing magnetic field. Answer C. Changing electric field. 10. An object of finite height is placed in front of a concave mirror within its focus. It forms A. A real enlarged image, B. A real diminished image, C. A virtual enlarged image, D. A virtual diminished image. Answer C. A virtual enlarged image. When an object is placed within the focus of a concave mirror, the rays of light after reflection appear to diverge from a point behind the mirror. Thus, the image formed is virtual, erect, and enlarged. 11. A beam of unpolarized light of intensity I0 is passed through a pair of Polaroids with their pass axes inclined at an angle of theta. The intensity of emergent light is equal to A. I0 cos square theta, B. I0 cos theta, C. I0 by 2 cos theta, D. I0 by 2 cos square theta. Answer D. I0 by 2 cos square theta. 12. Emission of electrons from a metal surface by heating it is called A. Photoelectric emission, B. Thermionic emission, C. Field emission, D. Secondary emission. Answer B. Thermionic emission. 13. When alpha particles are passed through a thin gold foil, most of them go undeviated because A. Most of the region in an atom is empty space, B. Alpha particles are positively charged particles, C. Alpha particles are heavier particles, D. Alpha particles move with high energy. Answer A. Most of the region in an atom is empty space. 14. Nuclei with same atomic number are called A. Isotopes, B. Isobars, C. Isomers, D. Isotones. Answer A. Isotopes. Isotopes, nuclei with same atomic number but different mass numbers. Isobars, nuclei with same mass number but different atomic numbers. Isomers, nuclei with same number of proton and neutrons but differ in their energy states. Isotones, isotones are atoms that have the same neutron number but different proton number. For example, 3616 sulfur, 3717 chlorine, 3818 argon, so on. In generally the elements are represented by capital X, or X is symbol of elements. A is mass number, which includes protons plus neutrons. And Z is atomic number, which includes only protons. 15. The column 1 is the list of materials and the column 2, the list of energy band gaps. G. Identify the correct match. Answer A. D. Conductors, these materials have no energy gap, meaning they can conduct electricity freely. Therefore, the energy band gap is G is equal to 0 electron volt. Insulators, these materials have a large energy band gap, typically greater than 3 electron volt, which prevents the flow of electricity. Semiconductors, these materials have a moderate energy band gap, usually less than 3 electron volt but greater than 0 electron volt. Here we finish 15 questions and answers of Part A of Model Question Paper 1. If you not subscribed yet, subscribe the channel for my efforts and for more updates. Let us move to next. Model Question Paper 2, Part A. 1. The total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by that surface. This is the statement of A. Coulomb's law in electrostatics, B. Gauss's law in magnetism, C. Gauss's law in electrostatics, D. Ampere's circuital law. Answer C. Gauss's law in electrostatics. Formula: phi is equal to Q by epsilon naught, where phi is electric flux. Q is total charge enclosed on surface. Epsilon naught is permittivity of free space. 2. The ferromagnetic material among the following is A. Copper, B. Nickel, C. Lead, D. Calcium. Answer B. Nickel. Ferromagnetic material are strongly attracted by a magnetic field. Some more examples are iron, nickel, cobalt, chromium dioxide, magnetite, dysprosium, gadolinium, etc. 3. Identify the wrong statement from the following. A. The drift speed acquired by free electrons per unit electric field is called mobility. B. The conductivity of semiconductors decreases with increase in temperature. C. The conductivity of conductors decreases with increase in temperature. D. Alloys are widely used in the construction of standard resistors. Answer. B. The conductivity of semiconductors decreases with increase in temperature. This statement is incorrect. Because the conductivity of semiconductors actually increases with an increase in temperature because more electrons gain enough energy to jump to the conduction band. 4. The physical quantities related to magnetism are listed in column 1 and the dimensions are listed in column 2. Identify the correct match from this table. Answer is D. The dimensional formula for a magnetic field is m, T to the power minus 2, A to the power minus 1. The dimensional formula for magnetic permeability is m, L, T to the power minus 2, A to the power minus 2. The dimensional formula for magnetic moment is L square, A. 5. The electric potential due to a negative point charge at a distance, r, is A. Positive and it varies as 1 by r square. B. Positive and it varies as 1 by r. C. Negative and it varies as 1 by r square. D. Negative and it varies as 1 by r. Answer. Negative and it varies as 1 by r. Electric potential. V is equal to minus kq divided by r. 6. The following are the statements related to self-inductance. 1. The self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. 2. The self-inductance is a measure of electrical inertia and opposes the change in current in the coil. A. Both the statements are wrong. B. Only statement 1 is correct. C. Both the statements are correct. D. Only statement 2 is correct. Answer. C. Both the statements are correct. 7. In a transformer, NP and NS are the number of turns present in its primary and secondary coils respectively. The transformer is said to be a step-up transformer if A. NP less than NS, B. NP greater than NS, C. NP is equal to NS, D. NP more greater than NS. Answer. A. NP less than NS. A transformer is said to be a step-up transformer if the number of turns in the secondary coil, NS, is greater than the number of turns in the primary coil, NP. 8. The expression for displacement current, ID is. Answer. B. ID is equal to mu naught, epsilon naught, d phi E by dt. 9. Identify the statement which is true for a compound microscope from the following. A. Its objective is a convex lens of greater aperture. B. Its eyepiece is a convex lens of smaller aperture. C. The image formed by its objective is real and inverted. D. Its eyepiece produces the final image, which is virtual and diminished. Answer. C. The image formed by its objective is real and inverted. For a compound microscope, the image formed by its objective is real and inverted. Therefore, the correct option is C. 10. Diffraction effect is exhibited by A. Only sound waves, B. Only light waves. C. Only matter waves, D. All types of waves. Answer. D. All types of waves. 11. In photoelectric effect experiment, if only the frequency of incident radiation is increased, then A. The maximum kinetic energy of photoelectrons decreases. B. The stopping potential increases. C. The photoelectric current increases. D. The photoelectric current decreases. Answer. B. The stopping potential increases. In the photoelectric effect experiment, if only the frequency of incident radiation is increased, the stopping potential increases. 12. The impact parameter is minimum in alpha, scattering experiment for the scattering angle of A. 180 degrees, B. 0 degrees, C. 120 degrees, D. 90 degrees. Answer. A. 180 degrees. This is because the alpha particle is deflected back along its path, indicating a close approach to the nucleus. The impact parameter is minimum when the scattering angle is maximum. 13. The standing wave pattern of matter waves associated with an electron revolving in a stable orbit is shown in the diagram. The principal quantum number, n, and radius, rn, of the orbit are respectively. From the above options, answer is D, 4 unto lambda by pi. 14. The radioactive decay in which very high energy photons are emitted is called A. Gamma decay, B. Alpha decay, C. Negative beta decay, D. Positive beta decay. Answer A. Gamma decay. 15. When a forward bias is applied to a p-n junction, it A. Raises the potential barrier, B. Reduces the majority carrier current to 0, C. Lowers the potential barrier, D. Raises the width of depletion region. Answer C. Lowers the potential barrier. Here we finish 15 questions and answers of Part A of Model Question Paper 2. Let us move to next. Model Question Paper 3, Part A. 1. The SI unit of surface charge density is A. Coulomb per meter, B. Coulomb per meter square, C. Coulomb per meter cube, D. kg per meter cube. Answer B. Coulomb per meter square. 2. The values of electric field, E, and electric potential, V, at any point on the equatorial plane of an electric dipole are such that A. E is equal to 0, V is equal to 0. B. E is equal to 0, V is not equal to 0. C. E is not equal to 0, V is equal to 0. D. E is not equal to 0, V is not equal to 0. Answer C. E is not equal to 0, V is equal to 0. For an electric dipole, the electric potential, V, at any point on the equatorial plane is 0 because the contributions from the positive and negative charges cancel each other out. The electric field, E, is not 0 on the equatorial plane because the field lines are perpendicular to the plane and do not cancel out. 3. If the potential difference across a capacitor is doubled, then the energy stored in it A. is doubled, B. is quadrupled, C. is halved, D. remains same. Answer B. is quadrupled. 4. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statements is correct? A. The drift speed of electron is constant. B. The drift speed of electron increases while moving from A to B. C. The drift speed of electron decreases while moving from A to B. D. The drift speed of electron varies randomly. Answer B. The drift speed of electron increases while moving from A to B. In a wire with a non-uniform cross-sectional area, the current I remains constant, but the cross-sectional area A changes. As the area A decreases, the drift speed Vd must increase to maintain the same current. Therefore, as the electrons move from point A, larger cross-sectional area, to point B, smaller cross-sectional area, the drift speed of the electrons increases. 5. A charged particle of charge q is moving in a uniform magnetic field. The angle between the velocity, v, of the charged particle and magnetic field, b, is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle for different possible values of angle theta. From the table, answer is B. That is, when theta is equal to 0 degrees, the trajectory is a straight line because the velocity is parallel to the magnetic field. When theta is equal to 45 degrees, the trajectory is a helix because the velocity has both parallel and perpendicular components to the magnetic field. When theta is equal to 90 degrees, the trajectory is a circle because the velocity is perpendicular to the magnetic field. 6. Below are the two statements related to magnetic flux and magnetic field lines. Statement 1. The net magnetic flux through any closed surface is 0. Statement 2. The number of magnetic field lines leaving the surface is balanced by the number of lines entering it. A. Both the statements 1 and 2 are correct and 2 is the correct explanation for 1. B. Both the statements 1 and 2 are correct and 2 is not the correct explanation for 1. C. Statement 1 is wrong but the statement 2 is correct. D. Statement 1 is correct but the statement 2 is wrong. Answer. A. Both the statements 1 and 2 are correct and 2 is the correct explanation for 1. According to Gauss's law for magnetism, the net magnetic flux through any closed surface is 0. This is because magnetic monopoles do not exist, and magnetic field lines form closed loops. Therefore, the number of magnetic field lines entering a closed surface is equal to the number of magnetic field lines leaving the surface. 7. The polarity of induced EMF in a coil is given by A. Lenz's law, B. Faraday's law, C. Gauss's law in magnetism, D. Ampere's circuital law. Answer. A. Lenz's law. 8. In a transformer, the windings of the primary and secondary coils are wound one over the other to reduce the energy loss due to A. Flux leakage, B. Resistance of the windings, C. Eddy currents, D. Hysteresis. Answer. A. Flux leakage. 9. The electromagnetic waves suitable for radar systems used in aircraft navigation are A. Gamma rays, B. Ultraviolet rays, C. Microwaves, D. Infrared waves. Answer. C. Microwaves. 10. A ray of light is incident on glass-air interface at an angle greater than the critical angle for the pair of media. Then the ray undergoes A. Refraction only, B. Partial reflection and partial refraction, C. Total internal reflection, D. Grazes the surface at the interface of the two media. Answer. C. Total internal reflection. 11. To observe sustained interference pattern on a screen placed at a suitable distance in Young's double-slit experiment, which of the following condition S's are necessary? A. Sources of light should be coherent, B. Sources of light should be narrow, C. Sources of light should be very close. A. Only A, B, both A and B, C. Both B and C, D. All A, B and C. Answer. Only A. 12. The de Broglie wavelength of a moving particle is independent of dash of the particle. A. Charge, B. Mass, C. Speed, D. Momentum. Answer. A. Charge. 13. For an electron revolving around the nucleus, A. Kinetic energy and potential energy are positive, total energy is negative. B. Kinetic energy is positive, potential energy and total energy are negative. C. Potential energy is negative, kinetic energy and total energy are positive. D. Kinetic energy and potential energy are negative, total energy is positive. Answer. B. Kinetic energy is positive, potential energy and total energy are negative. 14. The ratio of nuclear densities of 13Al27 and 29Cu64 is A. 1:1, B. 3:4, C. 13:29, D. 27:64. Answer. A. 1:1. Because nuclear density is essentially constant for all nuclei and is independent of the mass number, meaning the density of both nuclei will be the same. 15. The energy band gap in conductor, insulator and semiconductor are respectively E1, E2 and E3. The relation between them is A. E1 is equal to E2 is equal to E3, B. E1 less than E2 less than E3. C. E1 greater than E2 greater than E3, D. E1 less than E3 less than E2. Answer: D. E1 less than E3 less than E2. In terms of energy band gap, a conductor has the smallest gap, nearly zero, a semiconductor has a moderate gap, and an insulator has the largest gap. Here we finish last 15 questions and answers of Part A of Model Question Paper 3. If you like the video, don't forget to share and subscribe the channel for next Part B of Model Question Papers.